Welcome to the video on Schmitt trigger circuit. It is a wave shaping circuit used to generate square wave from a sine wave. It is also called as bistable circuit. Let us see the circuit diagram of Schmitt trigger. So this circuit contains two transistors Q1 and Q2. Now the collector of transistor Q1 can be connected to the input, that is what, to the base of Q1. The collector of Q1 can be connected to the base of Q1 through the resistor R1, but the collector of Q2 did not given to the base of Q1. So instead of that connection, the emitter of Q1 and Q2 can be coupled together. And VCC is the power supply. Here this VCC, RC1, this R1 and R2 will form a potential divided bias. And this Vin is the input. The input can be given to the base of the Q1. And this Re is nothing but as emitter resistance, and IE is the emitter current. So we already know that the emitter current equal to IB plus IC. Approximately the emitter current equal to IC, collector current, and V out is the output voltage. When the power supply is applied to the circuit, at initial condition the Q2 is on and the Q1 is off. So Q2 start to conduct and Q1 did not start to conduct. It is an off condition. When Q2 is on, the collector of Q2 and the emitter of Q2 are short circuited. So the voltage across the Q2 can be given as V out equal to Vc to saturation. And now the Q1 is off, so the collector and emitter of Q1 should be open circuited, and this is the first condition of this Schmitt trigger circuit. And when a sine wave which is applied to the input of base of Q1, the Q1 also have the negative bias resistance. So these components will make Q1 to on and Q2 should be off. And when Q1 should be on, the collector of Q1 and the emitter of Q1 should be short circuited, and the voltage across this Q1 Vc1 can be given to the input of the Q2, so that makes the Q2 should be off, and this process is going on. And this is the working principle of the Schmitt trigger circuit. Here in this Schmitt trigger, we should understand two important terms, that is UTP and LTP, upper trigger point and lower trigger point. So this graph shows the output waveform of Schmitt trigger circuit, and here this is the input graph and this one is called as the output graph. So we should know the two conditions. The first condition is when the input voltage is greater than UTP, it is equal to VCC. When the input voltage less than LTP, so LTP is nothing but as lower trigger point. When the input voltage is less than lower trigger point is equal to VCC minus IC2 into RC2. Yes. So when the transistor is going to start to conduct, that point, when the transistor is going to start to conduct, that point can be called as upper trigger point. So here in this input is sine waveform. In this point can be called as UTP. Let us project the point. Yes, and this is the area is called as VCC. When the sine wave reaches the LTP point, the output of voltage can be given as this one. This is called as VCC minus IC2 into R2. Again, when the sine wave reaches this positive maximum, this point, the output voltage should be given as VCC. Again, when it reaches LTP, this point, the output voltage V0 is equal to VCC minus IC2 into RC2. So that is the output waveform of Schmitt trigger circuit. And overall, the Schmitt trigger circuit is used to generate a square waveform by using a sine wave as input. Thank you.